Okay guys, today we're going to learn how we shift the graph of a trigonometric function. You're going to notice in today's lesson that the way that we shift trig functions is really the same way that we shift other functions such as quadratics, absolute values, linears. Okay, remember that let's take a look at the first one. How would we graph the change of y equals the sine of x if we go from y equals sine of x to y equals sine of x plus 2? Okay, what do you think would happen here? We're adding 2 to the sine of x, which means this is going to be a vertical shift, okay? And it's going to be shifted in which direction? Where do you think it's going to go? It's going to go 2 units up, okay? Now remember, you always have GeoGebra to use to help you visualize these graphs. So don't hesitate to plug them in and see how they're changing from one to the other. All right, and the second question, how do we graph y equals the sine of x change if we have y equals the sine of x plus 2? Now notice what's the difference between 1 and 2. In 1, we have 2 being added, no parentheses. It's being added to the sine of x, okay? And then in question 2, 2 is being added to x, so it's the sine of x plus 2. Now this refers to a horizontal shift. Remember, we're in the parentheses, horizontal shift. What direction are we going? The opposite of the sign. So this is going to be a shift 2 units left. Okay. And we can, like I said, we can always plug this in to GeoGebra. That's the regular y equals sine of x. And y equals sine of x plus 2. Notice how it's getting shifted up 2 units. Okay, and then if I make the change on the inside of the parentheses, now that red graph is being shifted 2 units to the left. Okay. All right, so here are just some formulas and notes to look back on to help guide you through today's lesson. Okay, again, just like we've talked about the last few days, A is the amplitude, absolute value of the amplitude. B, it represents the cycles. Okay, how many cycles do we have going from 0 to 2 pi? The period is 2 pi over B. Okay, B again represents the frequency. D stands for the vertical shift. If we're going and subtracting or adding anything to the inside of the parentheses, directly to x, it's a horizontal shift. Sometimes called a phase shift when b is equal to 1. Okay, so rules for horizontal shift. If we're shifting in this first graph, okay, notice that C is on the inside and it's positive, so it's going to be a shift to the left by C units. Okay, so we're going to the left, which really represents negative C. Okay, for the next graph, A equals the sine of B to the x minus C times x minus C. We're shifting to the right, and that's C units. This is a positive shift to the right. Okay, vertical shift, take it as it is. All right, this should be shift upward, D units, and this is a shift downward, negative D units. So those vertical shifts are always the most straightforward. It's the horizontal ones that are flipped around, okay, the opposite signs. Okay, state the shifts based on the function. Okay, here we have, well, let's start with the amplitude. Remember, amplitude is the absolute value of, in this case, 3. Okay, the frequency is going to be that number 2. So amplitude, absolute value. Frequency is this number here. What is the period? Okay, how do we find period? Remember, we take 2 pi over the frequency. In this case, it's 2. And therefore, our period is pi. Let's talk about the horizontal shifts. Okay, horizontal means going left and right. So what would the horizontal shift be here? Negative pi, because it's positive. The vertical shift is -1. Okay, next problem here. Amplitude is 2. Frequency is 4. For the period, again, 2 pi over the frequency, which is 4. And that's going to simplify to pi over 2. Okay. What's the horizontal shift? Because it's positive, remember, our shift is going to be negative. We're going to the left. Pi over 2 units. Vertical shift is going to be +1. Okay, now let's take a look at what a regions question would look like. The periodic graph below can be represented by the trigonometric equation y equals a cosine of bx plus c, where a, b, and c are real numbers. State the values of a, b, and c, and write an equation for the graph. Okay, so let's take a look at this because this is looking a little bit different from what we've seen so far. And if you notice, the reason's going to be, it kind of looks like it's been shifted up, right? Shifted up a little bit. So if it's being shifted up a little bit, we've got to take that into account before we identify the amplitude of our equation. Okay, so what I'm going to do here is I'm going to try and find like the middle of the graph, and I'm going to draw a horizontal line through this. Okay, notice that if I draw a horizontal line, this is kind of like if I were to just bring this back down and shift it back down to 0, okay, this would be where my x-axis would be. This is what we actually call the midline. Midline because it's the middle of the graph, okay? And in this case, the midline is y equals 1. That's the equation of the midline, okay? From there, if I count up to the top of the graph, I have 1, 2, 3 units, okay? 3 units. That represents my amplitude, okay? So for y equals a cosine b of x, I know that my amplitude is going to be 3. The next piece I need to find is the frequency. How can I find the frequency? Well, I'm going to look and see at my graph, my x-axis. This is taking me to pi, okay? If I have from 0 to pi, notice 1 full cosine curve. Well, how many would I have going from 0 to 2 pi? I would have 1 more cosine curve for a total of 2. Okay, remember the frequency always represents how many curves you have from 0 to 2 pi. So b value is going to be 2, okay, x. And how much did this shift? It went upward. We know it went up, okay? And it went up 1 unit. How do I know it's 1 unit? Because look at my midline. My midline is at y equals 1. How far away is that from the x-axis? It's 1 unit. It's in the positive, going towards the positives. So I know that I'm adding 1 to that. And if I wasn't totally sure, I can just always plug this into GeoGebra. Okay. And is that the right one? Y equals 3 cosine of 2x. Okay. And notice that that's what you're going to see. If I just spread this out a little bit more. All right. Notice that that's where it's intersecting the y-axis. Okay. At 4 is the highest point. The lowest point is -2. Okay. And I should have 2 full cosine curves once I get to 2 pi. And again, remember that 2 pi, if I take 3.14 and multiply it by 2, it's going to give me a little bit over 6, which would stop right there. Okay, just about right there. Actually, right up there. Okay, and that's 2 pi, 6.28 and a little bit, and then some. Okay, Next example we have here, we're going to do the same thing. Y equals A cosine bx plus c. Okay, again, I want to find that midline. So looking at this, and your eyes can really kind of tell you where the midline is. All right. If not right away, just try to locate the middle, and then what I'm going to do is put a point up here and a point down there. I should have, these 2 points should be the same distance away from the midline. All right, and notice here, 1, 2, 3, and then going in the other direction, 1, 2, 3. So that's how I know that that's my midline, okay? From the midline, you're counting up how many units? 3 units, so therefore our A value in this case, well, the amplitude is 3, but which direction am I going in from the beginning? I'm going up or down. Okay, because we're starting down here, that's going to be a negative 3. Okay, if I was starting up in the positives, then it would be positive 3. But because I'm starting at -5, that's going to be a -3. Okay, so negative cosine. How are we getting our B value? Again, remember the frequency. How many full cosine curves do I have going from 0 to 2 pi? 1, 2, 3, and 4. So let me put that in there. 4, x, and then, so now to come up with the C value, we need to know how this has been moved. Okay, we know that it's a vertical shift. How many units has it been moved? Again, go to that midline. What's your midline? The equation of the midline is y equals -2. That means our C value is going to be -2 because it's been shifted 2 units down from the x-axis. Okay, and we can plug it into GeoGebra to check our work. -3 cosine of 4x minus 2. Okay, and notice that they look identical. Okay. All right, let's take a look at the next one. Now we have a sine curve. Doing the same thing that we just did. Draw the midline. Identify the equation of the midline, which is y equals 2. Okay, so we already know what the C value is going to be. The C value is going to be 2. All right, y equals a sine of bx plus c. Our C value is going to be +2. Okay. For our A value, what's the amplitude? Notice the highest point on the graph is at 5. We're going from 2 to 5, so that's 3. Okay. So where are we starting from? When we start from here, are we going up or down? Okay, if we're going down, then that means that we're starting with a negative. So that's -3 sine of bx. Okay, what is the frequency? We have 2 full sine curves, so it's going to be 2x. Okay, and again, we can check that in there. And there we go. Might just look a little bit different because we're looking at a piece of it. Yep, there we go. Okay, next one, doing exactly the same thing. Locate that midline. Sorry that that's a little crooked. Equation of the midline is y equals -2. So let me write out the standard form here. Y equals a sine of bx plus d. We know d is going to be -2. Y equals, okay. What is the amplitude? We're going from -2 to +2. Okay, so -2, so from -2 to 0 is going to be 2 units. From 0 to +2 is going to be another 2. So that's a total of 4. And look here, from -2 to -6, that's going to be 4 units. So our A value, our amplitude is 4. And to determine whether it's positive or negative, see what you're doing here at this point. Since we're going up, it's positive. Y equals the sine of B of x. What's our B value? Again, how many full sine curves from 0 to 2 pi? 1, 2, 3. So our B value is 3. Okay, y equals 4 sine of 3x minus 2. Plug it in there to double check. And there we have it. Okay, take a look at the next one. Same thing. See, all these problems are doing exactly the same steps over and over again. Identify the midline. Okay, here's the midline. The equation of the midline is y equals -1. Okay, amplitude. We're going from the midline to the highest point on the graph, which is at 2. Our midline is at -1. There's 1, 2, 3 units in between the midline and the highest point. So that is our amplitude. Let me write this here. Y equals A sine of bx plus d. Amplitude we just stated is 3. Is it positive or negative? We're going in an upward direction first, so therefore it's positive. What's our B value? Remember, we're looking to see how many full sine curves we have from 0 to 2 pi. 1, 2. So B is 2. And our D value, how many units up or down has where is the midline from the origin, from the x-axis? It shifted down 1, so therefore our D value is -1. So I can put plus -1, or I can just simply write this as -1. Okay, double check that in GeoGebra, and you notice here. Okay, now let's take a look at this one. Okay, so this is an example of a Region 6-point question. The resting blood pressure of an adult patient can be modeled by the function P below, where P of T is the pressure in millimeters of mercury after time T in seconds. This is something we're going to make sure we want to remember, that T represents time in seconds. Okay, you see the formula that they give us, the equation, the function P of T equals 24 cosine of 3 pi T plus 120. And the domain that they want us to work over is from 0 to +2. Again, seconds. Now, the first thing that we want to do is graph our function. Again, plug it into GeoGebra. Okay, notice I have it already plugged down here. What I did was, since T represents the time, and we have 1 already on the graph, that's for us there, and this over here is going to represent 2. Those are the 2 values that I'm going to be plugging in. So I did that here, and I got 96. Okay, so therefore what I did was I plotted my first point at 196. That's representing the y value. So this is 1, 96. And then the second point here is at 2, 144. Because when I plug 2 seconds into the equation, I get 144. Now, going back, you can either plug in a 0 for T, okay? And if you plug in a 0 for T, you're going to also get 144, okay? Which is right here, which is your first point, okay? The other way that you could find that is, we know that the I'm losing my train of thought because my son's trying to ask me a question right now. Take the midline. Okay, where would the midline be? That would be 120, okay? Or basically the vertical shift is 120. And if you add that to the amplitude of 24, that's going to give you 144. So that's where you know that your first point's going to be. All right, and then we just connect those points to create the cosine function. Okay, now a couple of things here. We have to now answer some questions specific to this problem. The first thing that they want us to know is the period. Determine the period of P. Remember that the period we find by 2 pi over the frequency. Okay, you can tell here that the frequency in the equation, remember that the frequency is 3, right? 3 pi, because it's the coefficient of the variable. So the frequency is 3 pi, all right? You're dividing 2 pi by 3 pi, which gives you a period of 2/3. What does this mean in the context of this problem? That's what they want us to state, okay? It's telling us that, explain what this value represents in the given context. Normal resting blood pressure for an adult is 120/80. This means that the blood pressure oscillates between a maximum of 120 and a minimum of 80. Adults with high blood pressure above 140/90 and adults with low blood pressure below 90/60 may be at risk for health disorders. Classify the given patient's blood pressure as low, normal, or high, and explain your reasoning. So let's start with the period. The period is 2/3. Remember that the t value represents time in seconds. So since the period is 2/3, it means that the blood pressure takes 2/3 of a second to oscillate between the maximum and the minimum. Okay, that's what that means. Now let's classify the given patient's blood pressure. Notice that the highest it's reaching is 144 and the lowest is 96. And by the definitions that they gave us here, high blood pressure is above 140/90, low is below 90/60. 144/96 falls into high blood pressure category. So this person has high blood pressure. Okay, they may be at risk for health disorders. All right, I'm going to stop there. The other example I'm going to leave out for you. You don't need to do it. If you want to, by all means, have at it. But I think we have enough work in this lesson to tide you over for 2 days. So I'm going to make this a 2-day lesson, okay? I'm trying to not give you too much, okay, to have to deal with, especially with topics like these. And that, we're not in a classroom together working these problems out, but I'm really hoping that these videos are helpful. You're finding them helpful and easy to follow along with, okay? As always, remember, you can always reach out to me during my office hours via Hangouts, Remind, or email. All right, and hope to see you guys soon. Bye.